Next up is the meshing of our flip simulation. So let's head over to our scene where we left off. And I went ahead and ran the simulation, and this took, I think it was like 19 hours or something. So for this type, I think it's fine, especially considering the workstation that I am on. It's not the newest. So that should probably be faster on your machine, I guess. Now, just before we start going over the meshing process, let's quickly have a look at what we simulated. So let me pull over a flipbook here and then hit play. Nice, and we can really see our additional breakup water disturbance that is really helping here, breaking everything up. And especially in this area here in the beginning, just before when it starts to rise, when it starts to get close to the water surface, you see this getting disturbed and starting to break up and starting to break up. And then also here, as soon as it leaves or is in the air, and then it gets this additional disturbing velocity here, also lying on top of the ship, just so it gets a bit of breakup there and it isn't just boring flat lying on the top there, and there's like an additional motion that we really can see. Nice. And I think for the border, we'll have a look at that in a second, but this is really close here and here. So I think we placed them pretty well. So let's just have a look at this again. Yeah, I mean, due to the resolution of the simulation where we don't really see the ropes that much, I mean, you do see them going through the surface a bit here. There you see a tiny disturbance on the water surface here, but that's it from that. And now for the meshing part, what we want to do is we want to make sure that this is all flat, because we can especially see like here towards the end, if you have a look at this section here, this is going down quite a bit. So if we play through this really quickly, you can see the borders that are moving quite heavily. Also this corner here that is wobbling down, and this is something that we want to adjust in our meshing section. So we're first gonna just run the regular meshing, and then afterwards we're gonna modify the mesh that we get out of that. And so we're gonna be isolating this middle section here, and then the outer section, and then we're gonna be blending based off of fall off between those two, and setting the outer area to have a Y value of 0, just so we can blend this nicely with our ocean or with our lake. Because you can imagine if we have the lake surface here, and then this is just dropping down and then coming up again like this big wave here. Same for this area here. It's not going to blend, and that's something that we have to take care of. Obviously, we cannot. I mean, if you have the time and space, disk space, meaning you can simulate a bigger domain, but yeah, I think that would just be a waste of resources there. So let's jump over to Houdini, and first for our meshing here, we want to add in our geometries. So this is the ship collider, that's fine. Let's just add some additional ones here. So our ship, and then we'll have our, what is it, guns, I think. And I think that's it that we want to add for that part here, because we don't want to add the rope in there since it's so tiny. We also didn't add it to the pillar section, so we'll just leave that here. Then once we go in the meshing, let's just quickly go over the settings here, make sure everything is connected. So the bounding box is connected, the padding is fine, So we'll leave that as is. And in the next part here, let's just jump to manual mode here so we don't have to cook this right now. So this is our, let me just check here. Yeah, this is our position blend. This will not work for this case here. I mean, it will, but not how we wanted. So let's just quickly move this to the side. Flatten attributes, I think we'll keep that. So we'll just make some space here, drop this down to the bottom, and then take this convert and move this to the top, since we're going to be using the polygons there. And just reconnect that here. All right. So let's head over to our particle fluid surface and let's mesh this just so we can get started. And maybe let's pick a later frame. So 1150, let's see, let this cook for a while and then we'll come back. All right, so now we got our mesh together here. One thing that I think I forgot to mention this, and it wasn't an issue when building the pillars, is this rebuild SDF option. This goes ahead and basically rebuilds the incoming fluid surface, and we do not want that because this can cause some issues for some part. And I did have an issue here, since maybe you've noticed that as well when trying this out, that when this was set to full resolution, so basically the standard option, it would just give me the top part here, and when I changed this to rebuild none, now I get the full surface here. All right, so already looking pretty good. What we want to get started now is start to separate basically these areas here. And what we could do is we could grab the inner parts, but I think it's easier to select first the outer part, since this is the one part that is going to be connected, and inside we're going to have like a lot of pieces that are disconnected and stuff like that, and then basically invert that mask. So what we're going to do, let's just drop down a color node here. And I think we'll try to get this based on the vorticity. So after running through our convert, since this is spitting out a poly soup, and we do want the individual polygons here, drop down a color node and change this to ramp from attribute. And we will say vorticity. Oh, typo here, vorticity. There we go. And we already can see basically where are the inner parts and where are the outer parts. Set this to 1. And then on the inner part, we're going to go a bit lower like this. And now we basically have a selection of the outer area. Now to make this a bit softer, let's just drop down a smooth here and smooth our color. Just cancel this here. Don't want to smooth our position. And then use the color. Let's see what this gives us, just to soften up these hard edges here. And then we'll just be selecting everything that is full white. Let's go a bit higher here. So filter quality can go lower, since we don't need that exact, just want a bit of blur basically on it. And then let's go higher, something 30 maybe. Let's see. Yeah, that seems fine. Now let's blast everything that is greater than 0.5 or smaller. So CD is greater than 0.5, and change this to points. And basically now we got the inner shape, but we want to have the outer part. So let's just invert this, so delete non-selected. And now we have these outer parts. Now we do still have these small little pieces here. And so one way to get rid of this is just to measure the area. So basically, how big is this? And then keep the biggest part, or the biggest piece. And so let's just drop down a, what is it called? I think measure. And so what this will do is it will measure the area for each primitive. What we want is to have this for each basically for each connected piece. So let's just drop a connectivity sub here before, and this will just go ahead and find each piece that is connected together and then apply an attribute, which in this case has the name class, and then it just gives it a name. And then here, this is new, I think, since 2 versions or 3 versions, where you can basically accumulate per piece. And so we just say per piece, and then here specify that attribute, and then it just sums up all the little areas that it measured, which are connected, and then this gives us basically the size of each connected piece. And if we check here, we see one that has a fairly large size, and then if we go down, we have a couple that are really small, so like 7 or something, and then we have the really big one. And so now we can just go ahead and blast this. I mean, the old way would be that you would basically do connectivity, run through each piece, and then do an attribute promote, where you would promote it to detail and sum it up, and then promote it back to primitives. And this is basically what it's doing in here. So let's just say at area is smaller than 1000, then delete, and now we should be left with just the big piece. Now, one thing that we do notice here is that we have some points left here. And so what we can do here is just drop down a fuse, and in the fuse say that we want to remove all unused points, and then it will just get rid of those. And so we don't have them floating around in the top area there. Now, we will use this to transfer basically, transfer this back to our original mesh, and then have an inverted mask. So we're going to do an attribute transfer here, and just drop down 2 color nodes. The first one is going to be red, and the second one is going to be black for the initial one. So this is just like a basic color transfer that you've probably done a million times already. So hook this up here, and then in the attribute transfer, let's go for a smaller radius here. Since 10 is a bit too big, let's go for 1 or something. Yep, and that should be good. Let's make ourselves a bit more room down here. Just cancel this operation. There we go. And now we want to absolute this color and invert it so that we don't have any values that are bleeding, so to say. So let's just drop down another wrangle here. Quickly go in here, and if our color at CD is not equals to 0, then we want to set it to 1. So v at cd.x is equals to 1. And this will just make sure that we have either 1 or 0. And then let's go ahead and invert that. So v at color is equals to, and then we'll do our negative multiply plus 1. So v at cd.x times -1, and then plus 1. And then we should have this inverted. Very good. And now let's just blast everything that is 0. So now we get our center part. And then from this part, we're going to be doing our new transfer, which is basically going to be our soft fall off outwards. So CD is equals to 0, and then set this to points. And now we should just have the main sim area that we want to use. So again, drop down, attribute transfer, just so we can transfer this back and create a soft fall off here. I mean, there's a lot of techniques that you can do, and you already see this here. Let's go here and lower this back to 1 again, and then the blend radius, we'll set this to 3 or something. Yeah, and so this is basically our fall off outwards. Now again, as we had before, just soften this so we get rid of these weird edges there. before we connect it, let's just add in our color value here. Let's go for really, really high. So something like 50, let's go 70, and filter quality down to 1, so we don't need it to be that accurate. And then connect that. And now we have a nice fall off for our inner area. And then we will use this. Also, one thing that we will be using later is this, basically this hard mask that we have here. So just gonna store this here. So I'm gonna say f at border is equals to our v at cd.x, just so we store that here. And so now we have our nice mask. Let's just hook this up again here. So our fall off area, and we will be using this value here, or these values here, to modify the outer areas of the mesh and push them back to a Y position of 0. So to do this, we will use this, since we're using this as a mask, everything that is 1, that's where we want to apply it. So we have to invert this again. So same deal here. We could just copy this expression here, paste it in here, hook this up, and then we should have our inverted mask. There we go. Let's just disable our grid here. Yes. All right. So to modify our position, quickly get another angle here. And before we continue, let's just start to rename some of this stuff here. So this is basically our absolute color, and then invert. And then here we have CD invert. And then this is going to be our adjust position. And so we want to store a couple of these attributes that we're going to be using for our masking of our position. So we're going to first, the one that we're going to be using is the mask that we just created. So let's just store this. So float, this is going to be our border, is equals to our color X. And now the next, what we want is our height gradient. So basically everything that is higher than a certain value does not get this applied. And I think we already did this in this part here. So we can probably just go ahead and copy this section here. And same for the vorticity. So let's just grab that there. Where do we have it here? Adjust position. And then let's just add in these two here. And just for the vorticity, I think I want to go a bit higher just to clamp off enough of the area. So I'm going to go for 0.8 here, and then 1 and 1 and 0. That should be fine. For the position, I think we can leave this as is. And then let's adjust our position, our Y position. So V at P.Y is equals to, and then we're going to just mix between our incoming position. So that would be V at P.Y, and we're going to be mixing between 0. So the one that we're going to be leveling out. And this is going to be based off of all our masks that we have here. So that would be the height gradient times the border. Let's see what this does for us. And now I think we should have leveled out the outer areas. And so now we can feed this into our flatten attribute. And I guess we probably don't need that border attribute that we set up earlier. But just in case, we could probably store that as well with the export, and then maybe use that later for shading if we need. But I guess for now this should be fine. All right, so we flattened our border here. Let me just check this here. It seems fine. Everything that goes above, that's okay. But everything that does go below, like gets pulled down, that's something that we don't want to modify here. And so we could probably quickly check this with our color visualize here. I think, let me see if this is the one. Yeah. And so here we're just coloring based off of the Y position and going in the negative direction. So everything that is negative or negative 0.01 will become black, and everything that is level 0 will become 1. So we can see here this is all level 0 or higher. So this is 1, and then everything that is below, which you can see here is slowly going downwards, is black. And so this is what we get. And if we turn off our adjust position, we can see all this area here is already sunk and down below. We're probably not really going to see this. So this is just to blend this nicely with our lake. All right, so the next part here, we have the flatten attributes. That's fine. And then we have our splitting. Let's just check and make sure that this is working as we expect. So just jump right straight to the split and then see what we get here. Let's just go for the attribute delete, just so we get rid of the color attribute. And then here we can see our inner mesh, the one that will not get displaced. So this will definitely not have any displacement on it, especially like these waves here. And then we have our outer area, which is this one here, which is the one that will get displaced. All right, so this covers up the meshing section. Feel free to go ahead, cache this, and in the next part we're going to continue with our whitewater. Not sure, we don't think we have to change too much there, but just to go over it and make sure we have everything set up there.